the last 15 minutes here, we're going to look at a few of the resources that I linked. We're going to talk a little bit about, doing things, basically reading and understanding the documentation for APIs that people create so that you can then actually use them. There are as many ways to document APIs as there are to write them. So this is a website that has a list of a bunch of free APIs that you can use for testing and learning purposes. It has different color schemes, but we'll take a quick look. All right, so it has a bunch of different categories, and actually I realize I should probably go by category. So it has a ton of different categories, right? So anything that might ever interest you, right? Like animals or anime or books, crypto, if that's your sort of thing. Programming, oh, that's pretty cool, right? Photography, right? A bunch of things here. There's a ton of different APIs, right? At the end of the day, though, there's different colors here that are relevant to you. Cores, you don't have to worry about that too much. That's some advanced networking stuff. We're not going to get into cores. HTTPS just means that it's more secure. That one's not as important, but it's definitely preferred for this to be green. Green means yes, it is. So you don't care about the bottom color. You do care about the second color being green. And then the top color can be green, blue, or purple. Blue means that you need to have an API key. That typically means that you'll need to create an account with whoever is hosting that API as a service, a developer account, and then they'll give you access to a key that your app can use. They will also often charge you money for this key. So even though this is supposed to be a list of free APIs, they might have a free trial that expires after a month and then starts charging the credit card you had to provide, right? So be careful of the blue ones. They might try and get something from you that you don't want to give. Purple ones means that they use OAuth. OAuth is that pretty complicated 6-step process that I described during the lecture. You probably want to avoid OAuth for now. If you want to look into some more advanced stuff at some point, go for it, right? But typically OAuth services are going to have some sort of payment tier to actually get to the services that you want, right? And then green means there's nothing. There's no authorization, there's nothing. Now, the thing about green is that typically when you have a green service on this list, they do not allow folks to send them data to put in their own database. So you won't be able to post to them, right? You won't be able to post or put, right, add to the database that they are managing with their service. That's just because it's free and requires no authentication. Everyone in the world could do it, and they would end up paying exorbitant prices for their database, right? Because they're probably hosting the database in the cloud, right? So, green is much simpler and easier to use. You can use it in the way that I kind of showed on the slides without dealing with any authentication. But as a result, it's much simpler, right? And it's not going to have kind of post requests. It's not going to have, you're not going to have access to user data or anything like that. Your final project will only need to be with an API that uses green authentication here. You are not going to be building an app that deals with users unless you really, really want to. By default, what we're going to do is your app locally has its own database. You can store data in your own local database. And so you will, in your local database, store information like your favorite items that you've looked at or whatever, and the URL to access them. And then you can use that to get to that stuff, but that will all be local. You won't be modifying anything on an endpoint to do that. So that's kind of the thing. Yeah. So while you're browsing through this, you can run into all sorts of things. Here's one called PoetryDB. If you click on the link, over here for this, right, it's going to be, in books, I think. PoetryDB. You click on this, it takes you to this GitHub, okay? So whoever is hosting this service, this API service, they pick where it goes. Okay, so whatever they think good documentation is, that's what they send you to. Whoever wrote this API has some thoughts. They basically, it seems like they built the API for poets who don't know anything about programming. The way, like they talk about, why should poets care? The answer is blowing in the data winds. Internet technology is making words endlessly manipulable, and traditional poets and writers are getting left behind, right? Like, this is for a particular individual, right? Maybe it's not you, but, your choice. So the way that this works is that you'll typically send a URL, out, right? And you will get data back, okay? And, based on how you send this URL, you'll get data back in a particular way. The way that this individual has set this up is semi-complicated. The way that you construct your URLs for this service is semi-complicated. So it's a great example of how anyone writing a service can set up the URL scheme to be anything they want it to be. And you as a client need to deal with that. You have to basically use it however they intend. You're not going to be able to change it, right? So here they want you to put an input field, a search term, and all this other stuff, right? Now all these things are optional, and I feel like the way that they kind of try and teach this is kind of weird, right? And hard to parse. But the reality, at the end of the day, what they're basically saying is you can say you want to get authors or titles or lines or poems or whatever, and then you can apply filters and searches via a bunch of different additions to the parameters on the URL, right? For example, here, if you do this just /author, right, it will give you a list of all authors in their database, okay? And if you look at author Ernest Dowson, then it will give you the object for author Ernest Dowson, right? It's a random poem, it looks like, actually. Or no, not a random, sorry. I always miss this. See this out here, these square brackets? It's so important. This is a list of poems by Ernest Dowson. They just only happen to have one in their database. So, yeah. And you'll note it's coming back in JSON format, right? Yeah, so this is one API, right? And I have some code here, right, that does the access for this, right? Although I haven't tested it in a hot second, so we'll see what happens. But basically, here in our main, we create this while loop that just kind of iterates unless you put if you type anything into the terminal and hit enter, then it quits, right? That's what input.count equals 0, and I realize I should make this a little bigger for you. So read line just reads from the terminal, it goes into input, so we're just going to do this forever. And then whenever you hit enter, we're going to fetch a new random poem, and then we're going to print out the poem title and the poem author. We're not going to print out the poem itself just because they can be quite long. So yeah, let's just make sure that this works. Oh, is it executing that entire time? That's funny. So you hit enter, and it returns a poem, the Reaper and the Flowers, and then it does this, this tab here, /t, space, right, and then by Henry Wadsworth Longfellow. Cool. And then if we hit enter again, it gives us another one after a slight delay, right? Each of these is a network request going to this API and getting data back, okay? So if we command click into here, right, you hold command, you move over. I talked about this a little bit when looking at APIs, right? Technically, our poem client here is a type, and it has an API, an internal API that we're using, right? But that's the contract, right? We can call on instances of client, we can call its functions. That's an API. So we're going to call fetch new random poem. So let's take a look at this. So fetch new random poem. This is a version of that slide that I sent, or that I showed, where we were doing all those checks with actual error checking in it, right? So this is what it looks like to actually do the error checking for your HTTP requests, okay? So you create a URL, right? And then you throw this failed to parse URL, right? We couldn't create a URL error. And I've got this poem error enum that I've defined up here, right? Also, if you want to see what, the minimalist function that you could create that does this, that's this. Here, we're constantly using this exclamation mark, which basically says, hey, try this, and if it fails, crash the program, right? Terrible idea. Don't do it. It's good for like really quickly testing something, right? So anyway, so you can throw these different errors, right? You call URL session.shared data from URL. This one's really interesting. So before I showed you, you'd have to create like a URL request, right? Where you pass it a URL, and then you can do things like, change its body, right? And its method, right? Stuff like that. And then URL session data would take in a URL request. And it does when you use the for argument label. But if you use the from argument label, it just takes a URL. And it assumes that you're just doing a get request with no post data in the method body, right? It's just a quick shorthand for Swift. You'll note there's also a bunch of things called data task. These methods you will specifically see here in the definition of our popover here. They are not async, and they do not throw. These are the older way of doing things. They work more so with kind of synchronous dispatch QE style code. They use the word task, but it is that's a old URL session task concept, not related to the async await task concept that you have become familiar with. Basically, if you see data task or upload task or download task, you can kind of ignore those. We're not using those. We're using async await for this. So if you wanted to upload, instead of upload task, you would go down to here for like upload for, from, file. There's like a bunch of different overloads for it, right? Different ways to do it. So anyway, here we're doing this. We're getting the data specifically from this URL, and it just assumes that this is a GET request, and we don't have to actually create the request. We can just pass it a URL, right? We then unfold this tuple into the data and the response. As I mentioned before, the response type is a URL response. So if we go to response here, you can see that it's this URL response type here, right? URL response doesn't have error codes. It doesn't have HTTP codes on it because it might not be an HTTP response. So in order to get access to those codes, you need to unwrap it, right? You're not unwrap. You need to conditionally cast it, sorry, which is, response as question mark HTTP URL response. Like, hey, are you actually a HTTP URL response instance under the hood? If you are, then allow this HTTP response to please reference you as an HTTP URL response type moving forward, which it does, which means we now have access to status code, which is a property, and we can click in here and take a look at Swift's definitions, right? Returns the HTTP status code of the receiver, right? This is some pretty sparse documentation, but it's what they've got, right? And this is that sort of interface that I talked about, that it looks like a Swift file, but it's not really, because you don't have any of the function definitions in here. But yeah, learning how to read these is really important to being able to just investigate Apple's different libraries. So anyway, so we check to see if the status code is 200, and if it is not, right, because we're guarding, right? So if it is, then we carry on. If this is not true, then we go into this block, and we throw it as an invalid response, and we pass, because this is a enum with an associated value up here, which is called code, and it's an int. We can actually pass the code here. So our thrown error can have a code embedded into it, which is really, really dope. Something I love about Swift. Typically, when you throw errors, you would have to have an error for each different kind of code, and then throw each individual error, which just it's awful. So, but we can do this instead, which is nice. Then we decode the array of poems again, because we always have to remember, say the service might return an array, even if it's only returning one thing, right? And then we do a guard let poem equal poems.first. Poems.first could be nil because poems is an array, and the .first property on an array might be nil. It's optional. So we have to unwrap that using a guard let. And if we can't, then we know that we have an empty list, basically. So we got an empty list back, so we throw that as an error. And then we can return that first poem as a poem type. And our poem type here is just a struct that is codable. And we have a title, we have an author, those are strings, and we have lines that is an array of strings. And that matches with the response that we would expect from a poem here. Now this API, it's kind of hard to tell exactly what all, the model is. They don't have a very clear definition of the model here. And that's just something you'll have to, learn to figure out. Like here, here's a result. This is a full model. So this is a model that gives everything back. It has a title, an author, an array of lines, and then a line count. You'll note our struct didn't have a line count because we can very easily get a line count by doing lines.count. It's an array of lines. So we don't need that. So we just discard it. Other APIs look a little bit more like this, right? This one has a bunch of your routes, it has parameters, and a bunch of other things, right? This is an API for getting information about Nintendo's amiibos. I don't know if you like amiibos, but I do. I built a while I was kind of learning some stuff like a few months ago when I was learning some SwiftUI things, I built a little amiibo viewer app that kind of lets you browse and look through the different amiibos that Nintendo has created over time. And I can show that sometime. I'll do it after class if anyone's interested. But that I'll also probably we can go over it during the SwiftUI lectures, which are next actually. So yeah, this API is nice. It's very simple. This is one of the few free APIs you can get that you can actually do posts to that actually changes data on the service, which is really cool. That's because they've made sure it's very, very simple. Basically, you can create counters that you are then allowed to increment and decrement, or just set to a specific value. That's it. That's all the API does. But it's great for practice. So actually, this is probably going to be I realized I said before the assignment was going to be one of these, like a different one. What I meant to say was the assignment will be this. You're basically going to use the counter API to make an asynchronous counter that you use in the terminal. I still haven't written up the spec for it. Apologies, that'll be available to you by tomorrow morning. Before I'd talked about how maintaining models across different clients and servers can be difficult and making sure that they all match. There are tools that help with that though. Tools like Swagger. Swagger is a tool that allows you to define models using a format called YAML. When you define models using YAML, which looks like this over here, right? You see how far I'm going with this, right? It is so big, right? It looks like this, right? It's kind of like JSON, but it's not exactly like JSON. It's specifically intended for routing stuff, right? But Swagger kind of lets you create models that match whatever's on the server. So you create a YAML file that defines your API. And then from that YAML file, you can run a kind of a code generator that will generate models that can be used in many different languages. And they will all interact with each other okay if they are encoded to JSON and then decoded back. They'll all be able to encode to and encode from JSON, right? And so like, for example, right here, you could, I don't know, for this API is this is a Star Trek API. It has a bunch of information about Star Trek in it, including all the different ships and everything. You can choose to do this thing called generate client, and Swift 6 isn't an option here, but we could click Swift 5, and that will take its time to do something, but Swagger basically will create a client that has all of the models and all of the functions that you can call via REST, and it's just all done for you, right? So that you can focus on your client, right? You will not be able to use Swagger for your final project. I am sorry. I'm showing this to you so that you can see what's possible in the future, but is it PodSpec? Will that open the whole thing? No. How do I open this in the... Okay, well, here. If we look at models, you can see they have all the different models in here, right? And they've all been auto-generated, okay? So Like they have this trading card, full, right? And this has all the stuff that the trading card, type would expect to have, right? And then they also have, other than the models, they have the APIs, right? The different, functions and stuff that you can call. Like there's a spacecraft API that lets you do queries on spacecraft that exist in Star Trek, right? So this API, this function v1 get spacecraft, right? This does all of the stuff like for you. It builds a request, it sends it out, it does a completion block, etc. Now, Swagger in Swift 5, it generates it using like the old dispatch queue style of asynchronous stuff, which is why we're not using it for our final project. But it's cool, right? It does all of this sort of API generation for you so that you just have to worry about like building your app and then calling these functions and using the models, right? So hopefully, wherever you end up working, if you work on a native iOS app, they have a Swagger or similar definition for their API, because then that generates a client for you automatically. It's pretty cool. Yeah, so there's a bunch of different APIs. This is what it looks like for a streaming API, right? Which is a little bit different than your standard HTTP, right? And here's a little blog post that talks about how to stream ChatGPT's API, right? And as a result, when you use ChatGPT's API and you do it streaming like this, you get this thing where it like each chunk of data has a GPT token, right? So it prints it in this kind of printing bit by bit by bit sort of way, which is how it looks when you're getting it from ChatGPT as well, which is pretty cool. Otherwise, if you called this function, or if you called this API, if you hit this API endpoint and didn't set it to stream, then you would have to wait for the whole thing to come back and then print it all at once. But because you're streaming it, you can get it all in asynchronously and just print it as it comes. Pretty cool. Yeah, so that's kind of like looking at APIs and how you kind of do it in Swift really, gently and lightly. So any questions about that? We are at 3:20, so I've had you here the whole time. I took you right up to the line. I am very sorry. But if there's no questions specifically in terms of admin, we are, I think, as I said, the assignment will be available to you tomorrow morning. The quiz won't be curved until the makeup's done. Yeah, that's pretty much it. Oh, did anyone mess around with the concurrency tutorial that I posted at all? Was that interesting? Like it was unfortunately high effort. So it was like, I don't know if it's a lot of bang for the amount of time it took. I don't know how good of a teaching tool it was. Was it decent or, I don't know. Okay.
The UI was cool.
The UI was cool. Well, yeah, but that's not what I did, right? That's Apple's automatic doc generation stuff. They have a whole system for generating a really cool tutorial UI. But what I did was basically just some Markdown files and a million different like Swift, code snippets, which is just it takes a long time. So cool. I should stop recording. We're at time.